Hello, everybody. Okay, so I've been playing with a 4090 RTX graphics card for the last couple weeks, and I have to say, for the way that I use iRacing in VR, it is an excellent upgrade. Um, this morning, I just wanted to run through and do some benchmarks, actually comparing processor differences. So I had been running with an AMD 5600X CPU, and I have another 5800X 3D that I bought back in April when they were released. At that time, I was running with a 3090 graphics card, and comparing the two processors, there was measurable improvement with the 5800X 3D, but not sufficiently better to be able to run any higher resolution or turn any significant options on or run in higher frame rate with the 3090. So now that I had the 4090, I wanted to do some comparisons and see if maybe with the elevated GPU capacity, whether that made the differences in the processors any more obvious. So like I said, I got the 4090 a couple weeks ago. It was kind of a challenge to fit it physically in my case, but once it's in, everything's relaxed. It's not under pressure, but I did have to like bend the chassis a little bit to get it to fit in. Um, and yeah, the initial performance, I mean, this is running on the 5600X, but the difference between the 5600X with the 4090 and the 5600X with the 3090 was significant as far as like the graphics comparison. I know 3D Mark is not a perfect benchmark or anything, but running iRacing, this was one of my initial runs after an hour-long Lotus 79 race. The temperatures were great. I was able to run 90 hertz with all the options that I normally ran previously with the 3090 at 75 hertz, and it was great. So experimenting with it more, my goal is to actually run a higher SteamVR resolution. I used to run at 110% SteamVR resolution, so the current goal is to run 150%. We'll get to that in a second. But the headset I'm using for VR is the Pimax 8KX. I like it very much. You know, getting it dialed in and running properly, I think, is a little bit challenging, and it does absolutely require the best computer you can afford. But in my experience, once it's running properly and you're getting the full optical focus as best as it can be, and you're dialed in with the settings and stuff and getting consistent frame rate, I believe that the field of view is pretty comparable to an automotive full-sized helmet, and what I feel in the car as far as my sense of presence and stuff like that is the best. So I enjoy the Pimax, but other people like the Index or the G2 or even the Oculus Quest. You know, there's lots of options and stuff, but I'm using the Pimax 8KX. So until yesterday, I was running with the 5600X AMD processor. I swapped it for the 5800X 3D, and what we're going to run through this morning is just some benchmarks and stuff to see the difference. And the benchmarks that I'm running are really specific to iRacing. And I wrote this little tool called the iRacing Data Logger that basically gets telemetry data. It's really simple. It's here on GitHub if you want to take a look. It takes values from iRacing as far as session information, but then the frame rate, the CPU usage foreground, the CPU usage background, the GPU usage, and that lets us graph and build charts and stuff so that we can visualize what's going on over time, either running the game real time or off of a replay. The way I've been doing my experiments is all based off of a specific replay. So I understand that might actually not be a totally valid performance if there's differences between running the game in an actual race session versus playing the replay. But I believe for the purpose of these kind of evaluations, that's exercising the systems and doing the graphics and getting the VR. I believe these are pretty representative cases. So my tool spits out comma-separated values, and then we can just pull them into Excel or Sheets or whatever to do graphs and visualizations. So these are the iRacing options that I'm running, and it's pretty much maxed out. I mean, there's really almost nothing to turn up from here. I'm not running the SSAO. In my tests, I can't see a difference, and it does significantly impact performance. So that's really the only option that I'm not that enthusiastic about. High quality trees I'm not running with because there's tracks like Hungaroring, where if you have that enabled, performance just plummets even on this system. So we don't have that. And the other option that I'll just call out is I run with crowds off. I don't think anybody's going to show up to a race that I'm participating in the real world. And the visual, crowds and stuff in the grandstands does not add anything to my experience. So that's the one option I just turn all the way off. I don't want to waste any cycles on crowds. It doesn't help my immersion. I'm happy with all of the other graphics options turned all the way up. The self shading and stuff like that. I also totally understand some people dismiss those kinds of options as superfluous, but having the sun cast a shadow based on the car number decal on the windshield as I'm making a turn really does pull me more into the world. So in any event, these are the options I'm running with. When I'm running in the game, I do have the dynamic LOD set to 85 frames, and have it so that it only deteriorates the quality on the world of the cars to try and improve. So if I am in a situation where for some reason frame rate has dropped, I do have it set so that it will, help out with those LOD options. But for the performance benchmarking that we're about to do, we're actually running a replay. So it's important to consider the replay settings. Those are pretty much identical. I have nothing that's lower in replay, and I don't really have anything else turned up. The only difference that I'll call out is that the dynamic LOD is set to off. So for the replay case, if we're suffering frame rate, I don't want iRacing to step in and try and adjust LODs to make frame rate. I want the benchmarking to show the frame rate that's being produced. So those are the options. In SteamVR, the way that I've been running is at 110% SteamVR resolution. Pi 2 quality is set at 1. And this is a really high resolution. I mean, if you think about it, 5,244 by 3,524, and that's just one eye. So it's actually twice that horizontally as far as what is being rendered all the time. And in my experience, 110% is pretty satisfactory as far as the image that you see in the headset. This is what it is actually rendering. And at 110% SteamVR, if we zoom all the way in, this is the 1-to-1 view. Your ability to read things in the distance is pretty good. The quality of everything that's close to you on the steering wheel, as far as being able to read the dials and stuff like that, is also really good. So with the either processor, the 5600X or the 5800X 3D and the 4090 graphics card, I can run 110% SteamVR with those options, and it makes 90 Hz frame rate no problem. And pretty much all the series that I run, car track combinations that I've tried, the performance is excellent. But if you look at the SteamVR page, this little tick here is what SteamVR recommends for my system. So what it's actually recommending is that we run 150% SteamVR resolution. So we're getting super sampling above, the baseline. That's a pretty crazy resolution. 6,124 by 4,116. Again, doubling that for, both eye rendering. This is what that looks like. And if we zoom in just to do a quick comparison, so that's 150% SteamVR resolution. This is 110% SteamVR resolution. The 110 looks pretty good. You can see stuff, but on this column, I can see the colors, but I can't really see what's there. In the 115%, I can actually see that there's 2 lines of text there now. And I can see that that's the little map of Laguna Seca and stuff. The quality, I mean, it's not a huge jump, but it is different. And in the sweet spot of the headset, you can absolutely see a difference between those two. I mean, I've taken the Pepsi challenge and tried, changing between them, and you can appreciate the difference in the sweet spot. The rest of the scene, you can't really tell. And that's where a killer feature comes in with the OpenXR options in iRacing and the ability to run with OpenXR Toolkit and enable fixed foveated rendering. So the truth is, if I try and run 150% SteamVR resolution with those options, it does not make 90 hertz by quite some margin. It's not making 90 hertz. If we enable the OpenXR toolkit and we set the fixed foveated rendering to render this resolution or this area at the full resolution, then I can make the frame rate. So fixed foveated rendering takes advantage of the idea that in the headset, the way the physical panels, optics, lenses, the whole thing works together, you can only see clearly in a sweet spot. And that's just a fact of life. And what I've done with my adjustments is set it so that this area is what I see clearly and even beyond. But it's set so that all the things that I look at as far as the in-game UI, my relative box, the times and stuff like that, is all within that area. So if I'm looking at stuff as I'm driving and just moving my eye around to see it, I have the best chance of seeing any of those things at full resolution clarity. The black area here, if we go to the next level, that next ring is being resolved at 1/4 of the actual resolution. The OpenXR toolkit gives you options so that you can do full resolution in the center, and then for the next ring you can do half resolution, 1/4 resolution, an 1/8 resolution, or 1/16 resolution. What I find is for this next range, running in 1/2 or 1/4, I can't tell the difference. It's already optically blurred and slightly distorted, so I can't see the difference between a half and a quarter, so I run at 1/4. And this outside region, the overwhelmingly large area on the screen, I actually run at 1/16 resolution. So this screenshot shows the whole thing, but I think this one is a little bit more illustrative. So you can see clearly the center area, that's what's being rendered in 100% 1:1, 150% SteamVR resolution. This outer area is running at 1/16 of that resolution. So if you look at any of the details over here, like, this Rolex sign and stuff, it's terrible. I mean, the aliasing, the chunky, it's low quality, low resolution. And if we compare that to the full resolution, it's like, wow, look how clear that is. I mean, you can see these support posts and the railing and everything. The Rolex crown is nice and sharp. Compare that to the 1/16 resolution. I mean, this is obviously deteriorated. But the truth is, I can't see it. When I'm looking straight ahead, this area is what I'm actually able to see through the lenses. This black area is where it starts to get a little fuzzy, and this further area, it's like I'm looking way over with my pupil if my head is facing forward, trying to see the things in that peripheral part of the vision. And the honest truth is, I cannot tell the difference between 1/16 resolution and 1/2 resolution. So I run it at 1/16. These are the options that I'm currently using in the OpenXR toolkit. My inner ring size is 40%. And then the middle resolution for that range where it does the transition drops to 1/4 resolution. And then my outer ring size is 55%, and that's being rendered at 1/16. So what does this actually look like? If we switch over to the way the game is running, so here it is, in real time. There's an option where you can set the middle resolution, and I have it currently set to cull, so that's why we see it as like the obvious black ring. And when I'm in the car with the view centered, what I actually see in the headset is within that interior resolution. I mean, obviously I can see the black circle, oval, ellipse, whatever, and I can see the far edges, but if I try to look over and see that same Rolex crown, I mean, I can see that it's green, and I can see that there's, sort of yellowish text over there, but I cannot see that. So I personally have gone back and forth with just the philosophy behind like fixed foveated rendering and stuff. And, I would tend to be a purist and say, I want the computer to render everything properly and, suffer the cost. But the truth is, I can't see it. And the performance advantage of running with the fixed foveated rendering lets me run with a absolutely clearly better sweet spot resolution than running at 110% and having everything rendered in full quality. So what I want to do is go through the benchmarks that I ran yesterday with the 5600X and see how the performance is with the 5800X 3D. So let me just reset this back so that it's in the normal configuration. And what I want to start with is just a baseline, which is running 110% SteamVR resolution, and we'll see that it totally makes 90 hertz frame rate. So we're going to quit the sim, change the display option back to OpenVR, and I'm going to go in and turn off the OpenXR Toolkit stuff. So it has this option where you can disable. So the service and stuff is still running, but it's no longer active. So we're running in OpenVR, and we're going to change the Steam resolution from 150% down to 110%. So this is the case that I'd been running. And like previously with the 3090 graphics card, this resolution with more conservative graphic options, I could run the Pimax at 75 hertz. When I switched to the 4090, I could run this resolution with higher graphics options and still make 90 hertz. And that seemed great. So what we're going to see now is that base case. And then we're going to look at what happens to the performance as we switch over to OpenXR and turn on the fixed foveated rendering. So we're going to launch the replay that I have. And this is not a perfect replay. It's just a representative first lap of a LMP2 race at Laguna Seca. It's a pretty full grid. Cars go off track. There's particles. There's chatter on the radio. It's representative. I know there are probably higher utilization, worst case track car combinations and stuff to use, but I've been using this replay and I just want to keep consistency. So I also want to run with the task manager up to show the system utilization. Switch to this view. Okay, so the replay is running, and this is my process for collecting the data. I go back to the beginning of the replay. I make sure that the headset is centered. I run my tool, which is this iRacing data logger, and it's waiting for a specific second in the telemetry data. So it won't actually start collecting samples until I begin the replay, and then it waits for a certain second in the replay to end the collection. So I always get exactly the same range when I run this replay with the tool the way it's configured now. So we go back to the sim, we start the replay, and we let it go. And we can see, just looking at the SteamVR performance output, that it's absolutely making frame rate. The budget for 90 hertz is 11.1 milliseconds. Most of the time we're less than 10 milliseconds. So this case, running 110% SteamVR resolution with the options the way I showed them, it is absolutely making frame rate. And it's consistent, and, it's great. So, like I said, this blew me away that I could go from the 3090 with conservative graphics options at 75 hertz, turn pretty much everything up, be able to run the same resolution, and do 90 hertz is an absolute win. So, my customer satisfaction in terms of making the investment and buying the 4090 GPU is absolutely, totally solid. I think is money well spent. And it's been a long time since there's been like a single component upgrade that's had like that level of, improvement. Sort of like back in the old days where you buy a new processor or a new graphics card or something, and suddenly you can run the games you play with all the options turned up until the next development cycle when they consider that the baseline. But okay, so the replay finished. And the data logger is no longer collecting samples, so we close that. And then up here, there's two screens. That's the game rig, and that's the stream PC. So they're different computers. But I have Sheets running here, and this file explorer is just going across the network to get to where the data output is. So this was the 5800X3D running OpenVR at 110%. And it was running with fully wait for sync, which is a graphics option that you have the option in OpenVR to enable. And in iRacing, that reveals what the CPU utilization is to an extent. In OpenVR, if you're making frame rate and you don't have fully wait for sync, then you don't actually get exposed what the R meter or what the CPU utilization is. So this fully wait for sync option shows it, but we're going to run and see that it actually, I think, affects just the way the values are being presented. But in any event, it's the way to see the frame rate. In Sheets, we're going to import, upload, drag and drop the file, and we're going to create a new spreadsheet is fine. Actually, no, I want to insert a new sheet. Okay, so this is what came in from the data logger. And the easiest thing to do is just grab these columns, have it produce a chart, and boom. This blue line is frame rate. There's a couple little dips there, but that's nothing that I'm concerned about. And then the green line is the GPU utilization, and the yellow line is the CPU utilization, and this red line down here is the background CPU utilization, which I'm led to believe is actually like just the physics processing and stuff that's not related to the render thread. So in this case, we can see it's absolutely making frame rate, and the GPU and the CPU are doing work that changes over time, during the replay. But nothing's saturated or pegged, and we're not seeing drastic swings in utilization. So there's one more little bit of data. If we go back to this spreadsheet and we grab these cells, we copy them. It's just the formulas, so it's actually getting the data, obviously, from the other columns. If we paste that in, that gives us the average, maximum, and minimum for the frame rate and CPU utilization and GPU utilizations. So with those selected, if we insert a chart, it gives us this nice little bar graph. And that's sort of the framework that we can use for comparing the run. Okay, so this first run was a baseline. It's running OpenVR with fully wait for sync at 110% SteamVR resolution. That's the resolution on the screen. And it totally makes 90 hertz. So no mystery there. And the 5600X made 90 hertz at this configuration. The 5800X 3D totally makes it too. We'll take a look at what like the CPU utilizations and stuff are comparing the processors later, but in this run through, I just want to mostly collect the data, and then we'll save the analysis for once everything's been collected. So what we're going to do now is we're going to change no options except for the SteamVR resolution. So it was at 110%. And if we put that up to the little tick that SteamVR is suggesting, we run 150%. And that's 6,124 by 4,116. That's a lot of pixels, especially if you consider that the horizontal resolution is actually doubled for what it's rendering. So we're going to run the exact same replay with the exact same configuration, still in OpenVR. And observe, at least with the 5600X, it did not make frame rate. I don't think the 5800X 3D is going to make frame rate either, but that's why I want to do these experiments. So we're now moving into the first real experiment after the baseline. Okay, so here we are back in the replay. Rewind, reset the head position, run the tool, collect the data. And the other thing, I want to record this on video so that I have reference to go back and look at the CPU utilization on the task manager and stuff like that isn't really captured in the CSV data that we're getting from the tool. Because there is an interesting thing once OpenXR is enabled with the 5600X CPU, one of the cores actually does get totally saturated. And I'm curious to see if we see the same behavior and phenomena with the 5800X 3D. So the data collection has ended. We close the tool, go back up to the other computer, rename the file so that it's representative of what we collected. This was still OpenVR, but it is now 150%, and it's fully wait for sync. Okay, so we go in Sheets, File, Import, Upload, drag and drop. We're going to insert a new sheet, import data, boom, grab the columns, insert the chart, it's them, and make the other chart. Interesting. So it did hit 90 hertz occasionally, but not in any flatline, constantly making frame rate situation. So it's interesting. 110% SteamVR, absolutely making frame rate, room to breathe for the CPU and the GPU. Running 150% SteamVR, not making frame rate, and quite a bit more noise. We just look. Interesting how the GPU utilization is significantly more elevated than the CPU utilization, but it's also curious that we have these sort of much more spiky sections in the CPU utilization. Okay, so the next experiment is to run everything the same SteamVR resolution, still in OpenVR, but we're going to change that fully wait for sync option. So if we go into the render OpenVR config and we search for fully, we find fully wait for sync, currently set to 1. Like I said, this value needs to be 1 to reveal the CPU utilization if you're actually making frame rate. In this case, we're not making frame rate, so I want to see how the CPU utilization is reported with this option turned off. So we're going to save that and rerun the exact same test. So we're changing nothing. We're still running OpenVR, still running 150% SteamVR resolution, but it's OpenVR plain, so I guess is what I would call it in terms of not being the fully wait for sync. So this is test number 2. It's OpenVR without fully wait for sync, 150% SteamVR resolution, and we'll see whether it makes frame rate or the costs are any different. I don't think that I would hope that turning that option on or off really does not affect the end frame rate very much. And I would hope that it really doesn't affect the GPU utilization very much, but it'll be curious to see how the presented CPU utilization changes. So that's the goal for this experiment. Okay, we're back in the sim. Reset the replay, reset the headset position, run the data logger, collect the data. So just looking at the SteamVR output here, I would actually say that we're not making as good frame rate. My recollection was that a lot of the time through that first turn 2 section and stuff, we were below 11 point. Okay, now we're down. I don't know. We'll see what the graph looks like. And that's the biggest sort of rationalization from my point of view to make the tool is to actually collect the data, look at it, and have clarity rather than, oh yeah, when I ran, it was green more often, or sort of speculative analysis like that. So that was my motivation for writing the data logger tool. It's not perfect, but it's getting the data that we have from iRacing. So, my goal was to make it so that as long as iRacing is what I'm trying to profile, regardless of whether I'm using OpenVR, OpenXR, what other tools and stuff are running in the background, I want that data output to be consistent and hopefully representative of what the actual performance is. So we'll see. Coming around the final turn. Okay, so that's the end of the replay. If we look at the data logger, it's finished collecting samples. Close the tool. Go up to the other computer and rename the file. So this was OpenVR 150, and that's it. So we're no longer running with fully wait for sync. Let's import that into the sheet. That's what the raw data looks like, but I wasn't trying to open it. Drag and drop. Insert a new sheet. It's columns. Chart. Grab these cells. Their chart. Okay, so this is running nowhere near frame rate, but it's interesting to me that without the fully wait for sync option, the consistency between what's being reported as the CPU utilization and the GPU utilization is too consistent. This looks, it's almost like they're just the same values, slightly offset from each other. If we just look at the green, the GPU utilization, it's different, but it's in the same range. The CPU utilization is completely higher running without fully wait for sync, and the way that it follows the contour of the GPU utilization makes me skeptical that that's really representative of the CPU utilization in fact. So not really sure what we see there. We just look at the blue line, which is the frame rate as it's being reported. Like I said, not huge differences. There are a couple changes to the contour, but in overall, we're in the same frame rate ballpark. Seriously, it's not a huge difference running with or without fully wait for sync. Okay, so the next experiment is going to be switching to OpenXR for the first time. And we're just going to run that plain. Without the OpenXR toolkit running and without changing any options. So we close the sim. In iRacing, we changed the display mode from OpenVR to OpenXR. I'm going to just confirm. I know I changed it earlier, but right now, the OpenXR Toolkit, the software is installed and it's there, but it has this option to disable it, so it should not interfere or cause any system overhead in this way. Hey, P. Darwin. So we're going to run the exact same test, but the change in this case is we're now running in OpenXR. And we'll see what the difference in performance is between, trying to run 150% SteamVR with OpenVR versus OpenXR. That's what this experiment should show. Alrighty, here we are on the replay. Reset the position, reset the start. Run the iRacing data logger. Capture the data. Okay, so replay finished. The data logger stopped collecting data. Quit the tool. Go up here and rename the file. So this was our first OpenXR run. That's at 150. But it's plain. We're not running with any other options. So let's import, upload. Drag and drop. I feel like that Daft Punk song, Technologic. Buy it, zip it, drag it, drop it, click, unclick it, new rewrite it, whatever. I don't remember the actual lyrics, but you know what I'm talking about. So insert new sheet, import data, grab the columns, insert the chart, go grab the summary cells, their chart, take a quick look at what we see. So this was running OpenXR, and this is running OpenVR. They should be otherwise identical as far as like all the options in iRacing are the same, the Steam resolution's the same, but we suffer a performance cost. Our achieved frame rate falls, and that's just true. And it looks like the reported CPU utilization goes up too, but we're still seeing the phenomena where these two graphs are fairly identical. So I'm not really sure to trust that CPU utilization. Our GPU utilization also goes up slightly, but not tremendously. So the switch from OpenVR to OpenXR looks like frame rate comes down a little bit, GPU utilization goes up a little bit, and CPU utilization, I'm not sure I trust the numbers that we're seeing. So that looks like, the superficial observation is, wow, OpenXR we run with lower frame rate and higher GPU utilization. So it seems like there's a performance cost to running OpenXR. Okay, so the next test is going to be to enable the OpenXR Toolkit. But I'm going to turn off the optimization with the Fixed Foveated Rendering. So we'll run it just like we turned the toolkit on, but we're not using any of its actual features. So the OpenXR Toolkit is now enabled. And let's launch the replay. And I'm really curious to see whether we get a core on the CPU task manager reported as being fully utilized or not. Okay, so the replay is queued up. Run the data logger. Collect the data. In all cases, the task manager reports the GPU utilization as 99%. And it's also interesting that I never see it get above like the 64 degrees Celsius. There is actually one of the high temperatures that I've seen. Okay, so the replay's finished. This was OpenXR Toolkit enabled, but nothing really running. So we stop the data logger, rename the file. This was OpenXR. $150. With the toolkit. And let's pull it into Sheets. So I'm going to copy those cells ahead of time this time. So we go File, Import, Upload, drag and drop, insert a new sheet, graph these columns, paste in the cells, chart the summary. See what we've got. So in this case, the change is between OpenXR running just plain and OpenXR with the OpenXR toolkit running. So it looks to me like the GPU utilization is unaffected. I mean, there's some slight changes, but nothing tremendous. OpenXR, again, we see a performance cost. Our frame rate falls. Observation. And the reported CPU utilization goes up. But again, I'm not sure how to interpret that. I don't think the CPU utilization is really coming through from iRacing properly. So what I observe is that there's a cost when we switched from this is OpenXR or this is OpenVR to OpenXR. Our frame rate suffered, and then from OpenXR to running with the OpenXR toolkit, our frame rate suffers even more. So the contrast between running OpenVR and opening OpenXR with the toolkit, but without any option, any improvement features, it's a measurable difference. So the average here was 85.0. The average here was 77.8. If we're just looking at like average frame rates and stuff like that, you can say that running OpenVR, you get higher performance at lower utilization. If you run OpenXR with the OpenXR toolkit running, it's a non-trivial performance cost. But if we go in and actually turn on the fixed foveated rendering option, exit the menu, and then again, just for the sake of completeness, I'm going to stop and restart the sim so that it's loading fresh now with that option enabled. We'll see whether we get a performance increase or what the results are. We're running OpenXR with the OpenXR toolkit, but with the fixed foveated rendering configured the way I feel it's appropriate for me. The central high resolution area is conservative as far as being larger than what I feel like I actually see clearly through the optics in the headset. The mid-range drops down to 1/4 resolution, and I feel like I can't really discern the difference between 1/2 and 1/4. If I drop to 1/8, as I move my head around, I do see some aliasing and artifacts and stuff, so I run it at 1/4, and then the outside largest area is at 1/16 resolution. So, headset position, replay, rewind, start the data logger, capture the data. And it is interesting. I am not seeing the phenomena that we saw with the 5600X where a core got totally saturated whenever the XR toolkit was running. Okay. Data logger's finished collecting samples. Let's rename the file. This was OpenXR 150 with fixed foveated rendering. File, import, upload, drag and drop. Insert a new sheet, import the data, paste the summary, grab the columns, insert the chart, grab the summary cells, insert their chart. Okay, making frame rate. And let's see, the GPU utilization now is much flatter and lower. CPU utilization we're now seeing is a flat line, and that's just the phenomena that iRacing doesn't report the CPU utilization if you're making frame rate in OpenXR. So the case where we were running OpenVR at 150%, where it's trying to render 150% Steam resolution over the entire panel, absolutely fails to make frame rate, and the GPU utilization is average 59.5. If we switch to OpenXR and we enable the Toolkit Fixed Foveated Rendering, we now totally make frame rate, and our GPU utilization falls to 50.2 average. So along the way, it looks not encouraging. OpenVR, we're making, 85 average frame rate. Switching to OpenXR, we suffer and we go down to 82 average frame rate. Turning on the OpenXR toolkit but not enabling anything, we fall again to 77 average frame rate. But then if we actually turn on the fixed foveated rendering with conservative settings, boom, we're up to 90 frames and significantly lower GPU utilization. I don't think we can say anything about the CPU stuff. We can go back and look at what the CPU task manager graphs looked like, but that's sort of becoming speculative. So yeah. The comparison, and let's take a look. Okay, so this was the 5800X 3D. These were the runs I did yesterday. If we look at the 5600X 3D, or 5600X, its average GPU utilization was 49. So with the, it's not a big, it's probably within the realm of measurement or, differences between runs. But this is the 5600X, this is the 5800X 3D. So there's a couple little frame rate hicks that we see with the 5600X that we don't see with the 5800X 3D, but I don't think those are representative of a huge performance increase. The prior case where we were running OpenXR and we were not making frame rate with the toolkit enabled, if we compare that between the two processors, the 5600 averaged 78.2 frames, and the 5800X3D is higher at 77. No, it's lower. So our average frame rate is actually lower with the 5800X3D. Not a huge difference, but it's interesting that it's lower. Running OpenXR without the toolkit on the 5800X3D, that's what we had. If we look at the same chart for the 5600, '82 with the 58 average frame rate, 81 with the 56. Marginal difference. Going back to opening, or just OpenVR without any of the OpenXR stuff. Our average for the 5800 X3D was 85. And our average here was 83. So we see a little bit better performance with the 5800 X3D than we did with the 5600X in the just totally plain OpenVR configuration. Not a huge difference, and not anything that would allow us to run anything more. So interesting. I'm going to do a little bit more analysis and stuff and see if I can, clean up the charts a little bit and make it a little clearer, and obviously post on the forums and stuff with the results. But thanks for watching. This is mostly just an exercise in terms of collecting the data, and I wanted to compare today the runs on the 5800X3D compared to what we ran yesterday with the 5600X. What I'm seeing superficially is pretty much the same as we saw with the 3080 graphics card. There is marginal, measurable improvement with the 5800X3D, but it is not sufficient to be able to run any different options or increase frame rate or resolution or any significant enabling. But I don't know. Like I said, I'm going to do a little bit more analysis, clean up the data, and report back. So thanks for watching. Take it easy. Drive safe. BitGirl, end stream.
Ending stream. Please remain calm.